Well, I'm not sure how we're going to get this all started. I guess this is going to be kind of an open discussion. One person I never mentioned right before we broke is Drew Ewing. And Drew is with Streit, and Streit is a company we've just started working with this last season as well. So with surfactants and some foliar feed products as well. So they're in the booklet with the portfolio of all the products, or some of the products are in there, not all of them. There's a whole list of products. But anyway, just wanted to introduce Drew. Not sure how to start this. Has anybody got some questions just to start off, or do we need to bring up another question of our own here?
Yeah, I want 400 bushel yield. Help me out.
How are we going to do that, Dan?
Manure.
You want to answer that?
Yeah.
You know, it's ironic because I've dealt with several folks that have worked with Dowdy and Tula. I dealt with several folks that are at the MAC group. They are actually actively seeking out more help because it's like they recognize that these gentlemen have accomplished the goal. And by working with them more directly, they also will be able to accomplish the goal. And I've interviewed them at length about how they're trying to accomplish this and how many of you are actually achieving it. I said, if I didn't have a conscience, I guess I could be a rich man too. But the reality of it is, most of the people aren't getting where they want to be. Why is that? The answer is, they have focused most of their attention on nutrients. Nutrient density, nutrient quantity, nutrient availability. But they've not told them the whole story. The whole story is, most of those people have been putting on large quantities of manure for a large number of years. Now, if anybody's understanding the way plants work, the photosynthesis machine, carbon dioxide plus water in the presence of leaves gathering sunlight, yields glucose sugar, food, and releases oxygen. The number one limiting element to agricultural production is not nitrogen. It is not phosphorus nor potassium. It is carbon. And carbon must be a portion, the largest portion of nutrient to be able to support the photosynthesis machine. If you've put manure on for decades, the most important element in the manure is what? Carbon. So now what you've got is these guys are focusing in on themselves and not letting everybody else in on the secret that, oh my goodness, they're so proud of the fact that they've tried all these other products that they bring in for the people to talk about at their meetings, but they stand up and tell them they don't work on my farm. No, because what you finally did was you provided enough carbon in that system that if you release it, now all the nutrients that are in the soil have a chance to do what? Go somewhere and be meaningful. Go somewhere and be meaningful. If you just try to do yields of crop of any kind on just nutrients and you don't put any extra carbon in there, it's woefully wanting. Sure, you can grow a good crop. You might even get close to 300 and might get an average if you're lucky. But going on to those other levels requires huge amounts of carbon. And without that carbon, you're done. That's the reason why the people of the world who are in charge, the elitists and the governments, are trying to get carbon dioxide out of the atmosphere. If we have more carbon dioxide in the atmosphere, do we go more corn or less corn? More corn. How do you control people if you can't control the food? All right, that's my discussion on, you want 400 bushel corn? We can talk, but you better get some manure, because if you don't, we're not going to have a whole level out there.
You
Okay,
conspiracy
Dan.
theorist.
Yeah, that's right.
Okay,
CT.
if I'm willing to talk, as far as reaching 400 bushel an acre corn, we do have one guy that hit 411 on his research farm over at Guthrie Center a couple of years ago. And it was, as far as perfect ground, though, his CSR is 31 to 45. It's good for raising. 31 to 45 CSR. Dave, you want to stand up or wave your arm? He took his fields from averaging 170 to 80 bushel an acre and being dead by Labor Day most years. And all of a sudden, he was using products that controlled diseases that were not chloride or fluoride based. So anyhow, he used nitrogen stabilizers. He was using silica to capture more sunlight energy. You're using some of Rusty's stuff to prevent heat stress. All those things are available. There's no silver bullets out there. It's a systems approach. And I'll talk some about high yield soybeans tomorrow, but there's no silver bullets out there. You have to have a plan. You have to follow it. You have to know what products you're going to use, and then you have to procure the ingredients and have a good network to work across. And when I tell people, if you're going to raise high yield soybeans, and I ask how many people in here play checkers? How many play chess? How many are really good at chess? And the guys that are really good at chess make the best soybean growers because they're very systematic in their thinking and they think out every notch. That's why this biology thing is really interesting because, Martha Carlin's going to talk tomorrow, and for 13 to 15 years, a number of us have been working to try to find a product that will break Roundup down in the soil. And I'm consulting with a lot of people that had bad tar spot problems the last 2 years, and if they do, I'm going to tell them the first thing you have to use for next year is use her product to get rid of the herbicide residue in the soil, because if you're short on minerals severely below the critical point, you're leaving the plant susceptible to disease effects that will kill the photosynthetic capability of that plant. So think plant health. Dave's corn, when it's harvest time, his hired man will say, you can't harvest that corn. It's so green, it's got to be 30% moisture. He goes out there and it's 18%, number one grain, 64-pound test weight, and the stalks are still green yet. So balance, plant health, and then not running out of mineral supplies, and then helping it with biological products that have been found by smaller companies. The big companies are not going to be innovative in the future. They're followers. So small companies, because the people that think of this stuff don't wear a leash very well. They're free thinkers, and they have to be. Yeah, Rick. Doug, excuse me.
You were talking about the manure before. Now, I do all grass, but how close do you have to spread your manure across the field? Will all those little bugs go across if you spread every 30 feet? Or are you just going to limit yourself to that spot?
That's a good question. The question, how close of the interval, if you're going to spread manure, do you need to be to get consistency out of it? Is that what,
Yeah, I mean, can I spread my bolts out, or do I have to be right side by side?
And you spread them out farther apart, or be right side by side. My suspicion is, and this is just an opinion because I don't know the actual answer, I haven't studied it myself, but common sense tells us that where we have less food in certain areas, we're going to have less biological activity for an extended period of time. If we're looking at the most ability to get yield from a crop, it's going to come from what? Number one, uniformity. So if you want uniformity in that situation, and you want biology working as uniformly as you can get it to be, which, what I do is I inoculate the stands with biology purposefully, not to try and tell you, let's say you don't have, if you ask me, do I have Bacillus subtilis in my soil? Yes. Then why do I need to buy this one? Because what you need to do is have Bacillus subtilis with every single seed, and Pseudomonas with every seed, and Xanthobacter with every seed. You need to develop that uniformity. So my response to that would be, as close as you can get to getting that even distribution, the more consistent you're going to be in improving yield potential because of the uniformity. Does that make sense?
Yeah, the microbes need to eat. Question came up earlier as far as what phosphorus levels are actually low. We always tell people, look at, if you go to Midwest Lab, look at both P1 and P2. If your P2 level is more than 25% higher than P1, you may not have a phosphorus supply problem, you've got a phosphorus availability problem. And the microbe that breaks it loose is called Pseudomonas fluorescens. The other role it has is it produces 4 toxins that kill fusarium. So people that have fusarium problems in small grains or any other crop, the most common cause of it is the Roundup in the soil is killing off the Pseudomonas. In the animal's gut, it kills off the Lactobacillus, Enterococcus, and Bifidobacteria, and then the E. coli, Salmonella, and Clostridium thrive.
Bob, if you stick zinc in there with that to make that pea more available, how much does that help?
Zinc?
Yeah.
Well, zinc is a critical element in that it's very fungicidal in its properties. Plants use it to avoid drought. It fights drought quite well, most important for that. And then also it basically determines the thickness of the cuticle on the root to prevent root infection.
So does that make the phosphorus more available if the P1 and P2 is spread out too much?
Well, if your phosphorus is too high, then you're going to probably tie up zinc and you have a greater need to put on zinc that year. Now, questions come up. Do you have to put on a lot of phosphorus on the soil? I guess my opinion is probably a little bit different out here, but I've been working with amino acid chelated minerals the last 3 years, and to me, they're going to be the miracle fertilizer the next few years, because instead of putting on pounds or tens of pounds, you can deal with ounces and having a huge effect. So fertilizer efficiency to keep the cost down. As the price for valuable metals increases, that takes with it the price for the cost for the micronutrients, manganese and zinc, and copper.
Let me, before we go to the next question, let me, also, when we're talking about all this with the biological activity, we have to also, back to the whole idea of the 400 bushel corn and carbon, we don't always have to use the manure. The manure brings us amino acids and proteins and other things for food sources. But carbon can be used in all forms and fashions. George is sitting right next to me here, and he'd love to hear you, somebody say, hey, I'd love to use more carbon. Can I use more carbon works? Will that work, George?
Yes, sir.
Okay, all right, see, but the whole point is, you have to figure out some way to get a food source for all these microbes. You have to marry in the whole idea of the pieces of the puzzle to make them efficient, give them a food source, make them efficient, get them there, sustain them, and you're off to the races.
So microbes actually cross-feed each other. So we design working systems of microbes. So you get logarithmic growth, and then you'll get a stationary and a die-off phase, and then the cell wall components and any of the metabolites that that microbe has made will, feed another profile of bacteria. And so what we do in our microbial systems that we build are sustained living systems that cross-feed each other using flux balance technology. And so, yes, it's probably a good idea to get them, closer to your plant, but as they grow logarithmically, you're going to get a sustained culture of organisms that are producing food for each other and your plant in the soil and pulling nitrogen from the air and putting it down into the soil. So, on the human side of things, a lot of times people are looking at probiotics and there's like one strain of bacteria, or, there's only about a dozen on the market if you go look in a commercial place. But if you build actually a working system that does something, you can produce the metabolites you want in a working system that is sustained over time and rebuild your soil. And good quality manure that doesn't have glyphosate in it will have those working systems, but if you're using manure from animals that have been fed with GMO feed, you are going to have glyphosate and you're not going to have a sustained system.
Don Huber would agree with you. We had a question over here.
I had a comment on it. Connected to the biology component, it really is about metabolism versus the mineral component, which is structure and And when you have a metabolism in that soil that's being promoted by the plant itself, I have other charts and papers we can show you, but nearly a 2/3 increase in zinc, nearly a doubling of the manganese, and that's not because we added it. It's because we added the creatures that eat it to make it available for the plant who wanted it.
What about molybdenum? I haven't heard that word today, and yet that's a mineral that you have to have maybe 3 ounces per acre. And I know it competes with sulfur. How does that fit into the carbon cycle?
Yeah. When I turn samples into Midwest Lab, I always ask them good questions. The guy that handles every single soil test result and signs every sheet, I asked him one time, being you do so many samples and I give a list of minerals to you, can you tell me what % of the time they're deficient? I said, I pretty well know what it's going to be, but I asked, how often is moly deficient in your tissue test? He says 95% of the time. How about boron? 90%. How about manganese? 80 to 85. How about zinc? 70 to 75. And usually I think of the great question, zinger, 50 miles down the road or a day later, and ask him how many other agronomists have come in there, how many university people have asked you the same question. He smiled and he said, you're the first one. Well, if you're trying to manage a crop, the low stave on the barrel theory holds. Dave Sassville was a micronutrient expert, or is, for the Midwest. He was at University of Missouri in the horticulture department, and he was author of one of the latest books on tissue testing. And he told a farmer, a friend of his, I forget what state, but he wanted to raise 300 bushel corn. He put on like 50 ton of cattle manure, so many pounds of anhydrous, sidedressed twice, put on AMS, and he got done. He had some real nice 190 bushel corn. And he wanted some answer as far as what happened. Dave tested his tissue from the corn plants for moly. He had virtually none. So the only way you're going to make efficient use of nitrogen is to apply moly, because it's essential for the nitrate reductive system and forming the enzyme that you need to convert nitrate nitrogen back into ammonia nitrogen, which is 17–18% more efficient and use of less plant energy. Plug for one of tomorrow's talk. Steve Applebaum is one of the guys that runs with Rick Mulvaney, David W. Johnson, and they're big into microbes and identifying ancient populations and ancient species. And he gave a talk at a food conference over in Hawaii I was at, and he gave a talk that both made the environmentalists happy and made the farmers happy, and I thought that was impossible. But how he laid out his thinking, he said the higher the carbon level is in your soil, the more food you got for the microbes. So instead of only having them fix 15 pounds of nitrogen, they might fix 50 or 80 pounds of nitrogen. He'll explain all that. And mistakenly, I think the environmentalists say our carbon dioxide level is too low, or is too high, and they want to sequester it in the soil, which is noble, but carbon dioxide is not a poison. It's a resource, and plants make sugar out of carbon dioxide, or sunlight, water, and carbon dioxide. We can't do that. Nobody else can except plants and lichen.
When a person is being developed after a couple have lateral gene transfer and there's fertilization and the body goes through a series of developments, the on switch to the human brain system that sparks life is molybdenum, and that's why I asked that question, because I haven't heard that word today. Who has another question?
One thing real quick before we get off the manure subject. What would be considered the Achilles heel, the limiting factor with manure? You've got carbon, but what else do you have to have? Two very important things that you can run out of. Hydrogen energy and oxygen. Because just like what we're talking about in the respiration of carbon, the plant sugar, where 50% of the photosynthetic sugar is actually being consumed by the soil biologicals, they need a food source, but they need the energy because they're going to release from that sugar respiration, they're going to release CO2 and water. But they're after the energy. That hydrogen positive ion is the definition of cation exchange capacity. You're trading a hydrogen ion and a nutrient at the root tip to bring in the nutrient to that hydrogen ion. That's the whole purpose of the biologicals, breaking that sugar down. Now, you might want to record this. Here the carbon guy, Carbon Works, is telling you that you can have too much carbon. You can. You can have too much of anything. I say here in Iowa, too much of a good thing is too much. And we know, and Larry has proven to me, and Jeremy, about too much manure on fields. It's a detrimental. So how can we help that situation? And with some very wonderful growers here, the Nelsons have been very instrumental in taking carbon as a truck, bringing energy and oxygen, and that's what we do at Carbon Works. We add the energy and oxygen very purposefully to pure carbon. You put it with your agronomy inputs and water, and then we deliver what might be missing when you have excess carbon. It's about that energy and oxygen because the respiration is not going to happen without the oxygen. Aerobic bacteria cannot respirate it. We know when a field gets flooded, what happens? Overnight, it goes upside down. Your corn went from beautiful green to John Deere rim yellow overnight, and it didn't happen because of lack of nutrients. It happened because the conversion was shut down. You basically drown the aerobic bacteria, the nitrosomonas and nitrobacter. Those are the ones that have to have oxygen to be able to convert that nutrient into plant available. So my point is that I have been on that north side of the line, the wrong side of the line, the state line, but in Minnesota, for 13 years now, Carbon Works has a product called Renew. It has not really been introduced here, but it's in your book. Larry provided it in the Agronomy RX book. But Renew is a very light carbon, pure carbon, but has a lot of energy and oxygen because by putting that into the manure, you will see an instantaneous reaction. There's no delay. And most manure guys, most producers are amazed that, like, they say, well, literally, that shit started working now. Well, that's what I'm trying to do. I'm trying to get your shit working, okay? I want it to have more of what you're after, and that's more nutrients available. And so where a lot of producers in Minnesota don't use their own hog manure, they sell it and they have it pumped. Of course, it has to be tested by a state lab to certify the NP and K analysis because that's what you're selling. Over 10 years, we actually, with the regular use of Renew in the pits, we were able to double the 10-year average of nutrient availability in that manure. So that's what we're here to help you with, is to understand that, yes, manure is great, but it's anaerobic. We got to turn it aerobic. Those aerobic bacteria are there, but we can add other beneficial biologicals, but you better bring along a pail of energy and oxygen.
Art has a question. Actually, he helped answer it because I was going to say that not all manure is created equal. And just like feeding a cow, you got to make sure she has plenty of fiber. And feeding our guts, our microbiome, we need fiber, not necessarily for us, but for the bugs we want to promote that turn our genes on and off. So my question has to do with phytase. Phytase is an enzyme that breaks down phytate, and phytate is what hangs on to phosphorus and keeps it from washing away like nitrogen does when you have a heavy rain. But we use all this, now we stabilize the phytase that we put in hog feed. And so on some farms, I've worked for a pair of brothers that still have some indoor-outdoor facilities and on their home place, and they use round bales of corn stalks to bed the pigs. And then they got 2 new buildings where they put the manure in an old dairy tanker and haul it to the farm they purchased that has 10-point better corn suitability rating, and then they're swearing up and down, even though all those pigs are fed the same way, whether they're out in a bedding pack, they're swearing up and down because they got to add commercial phosphorus to their black soil that's better, where they're hauling the liquid stuff as opposed to the other. And yet then I debate with Iowa State and try to figure this out, and they're telling me, well, by the time phytase, the definition of an enzyme is it can be used multiple times in a reaction. And so I'm asking them, can that new stabilized stuff that they're making now to put in the premix, because they don't have to spray it on after the pelleting process, can some of that still be left coming out of the back of the pig and still working in the pit and out in the field? So maybe that's, where's that phosphorus going? You know, is it, if you don't have phytate in the field to hold it there, is it leaching away just like nitrogen does? All the studies on this, they try to assure me that they've proven that the phytase is used up in the pig, but all the studies I can find were done on the old phytases before they stabilized it. So this doesn't happen on every farm, but it happens on more than the one I gave as an example. Any answers? And then my comment on molybdenum is now we aren't poisoning sheep anymore with copper toxicosis, because most of them are eating Roundup diets. And copper is actually its favorite mineral. Copper is first, and then zinc, if you look at the K values for it, and cobalt and manganese is down a little farther. But anyway, what we're finding out, molybdenum, like Bob says, you have to have it for nitrate reductase. Well, we need it. The bacteria in our mouth, 5 to 10% of the nitric oxide we need to make our pylorus swell up, to shut our valve, so proteins, infectious viruses, or proteins we're eating can sit in the stomach and be in there long enough for the hydrochloric acid and the pepsin to break them down. 5 to 10% of that nitric oxide we get because of molybdenum's work in the nitrate reductase. You got to go from nitrate to nitrite and then to nitric oxide. Well, if 95% of our soils are low, and so my partner and I, we took the sheep product that we don't need anymore because we don't have poisoned sheep with copper, so we got this cheap 50-pound bag of 2,000 parts per million sodium molybdenate sitting around. So we started putting in half a pound. You sure don't want to overdo any of these things, including selenium. But anyway, we're putting half a pound of that in all our hog rations for our independents, if they're working with a small feed firm that'll listen to us. And it's helped on bloody bowel. I think it's even helped a little on PRRS. So you're exposed to all these viruses orally. And if you keep them in the stomach long enough, you break them into amino acids, so you got a lower infective dose. And if you digest you got to break your proteins down in the stomach, so they aren't complete proteins in the bowel. That's when you get all this fermentation that isn't even supposed to go on down there. So sorry to yak so much, but comments.
That was a real long question. It sounds like there's byproducts that are supposed to be not going out the back door in the compost, but it is going out the back door, and what's keeping it running away from the soil? I mean, does anybody want to tackle that question?
Well, that's what CEC is.
All right. Nobody wants to tackle that.
I'll tackle it. It's bound up in the biology. This is where we have cobalt and calcium and manganese and all those things, and when they have the nutrient cycling with the other animals, they eat one and pee and poop out the rest that they don't need. That's the excess. That's the water-soluble nutrition. So we had depending on the two types of phosphorus, 30 to 60% increase in availability of phosphorus. And that's because of the biology, and specifically the fungal components. If in this discussion we just talked about bacteria, we're not still getting the full complement of biology that wants to complement our growing practices. So, but it's in the biology that's in the soil, and if it's not, then it's being washed out through erosion.
Art has a real interesting point when it comes to saliva. It doesn't matter if it's an animal or human. The iodine, the number one place you'll find it is your thyroid. It's also found in reproductive organs, but the biggest amount of it, second to the thyroid, is actually your saliva glands. And it goes into your saliva glands, so it controls the microbiome of your mouth. And if you don't have any iodine in your mouth, you have the wrong microbiome, and you're constantly inhaling and swallowing all the wrong products, no matter what life it is, and it causes for dysbiosis. And this iodine factor, because I called Bob, I said, what do you got with sea kelp in it? He says, Dr. Paul Detloff and I did a study. We got this company that's called Organic Valley, and he says, I want to prove the girls are doing really good on sea kelp. So we got a bunch of hair off the heads of cows that were Organic Valley on sea kelp and conventional cows without sea kelp. And we found a 5,400% increase in iodine in the fur, a 250% increase in boron in the fur. We found that the lead, the mercury, the cadmium were all lower just by the addition of the sea kelp to the animals. And when fly control and all the issues that it takes to have DNA be responsive to the micro or macro environment, I'm like, what do you got with iodine? You need to get a lot of iodine. Please don't use anything from the Pacific Ocean. So I said, well, where are you getting your iodine when you got it? And they said, well, they think it's the American Kelp Company, which I strongly advise. You have the Thorvin Kelp Company, who was a wonderful company, but they sold to the Chinese. That leaves the Labrador Kelp Company, and they all have different types of kelp. But you need to seriously look at this kelp. I had a lady come in, and she had tears running down her face, and between sobs, I go, what's the matter? She said, my son moves home. I said, is your son Charles Manson? And she said, no, he brought a herd of cows that were vaccinated, and all my girls are dropping dead. I've lost 8 girls. So I called Detloff, I called Paul, this is what's going on. He says, you can't get a bag of sea kelp fast enough there. We went and got there, dumped it on the ground, and the cows ate the sea kelp, and they did not lose another cow. And these cows ate that sea kelp like there was no tomorrow, and they ate it like they were going to save their lives. And I would strongly, I always, when it comes to these minerals, I don't think you can do better for a broad spectrum amount of all the trace minerals when you're looking at sea kelp. And I know there's a lot of people that say, well, our soil has these minerals, you got to have the right tea compost, you got to have all this other stuff in it. I'm like, well, I'm doing from the 50s that we weren't going to have minerals in the 60s. In the 60s, they developed nitrogen, and all we got out of that was meth. Next question. Who has a question? Got to have more questions on that.
Over here.
Yeah, I got a question for Vatche.
Yes, sir.
So I've got an organic farm, but I will bring in some manure from time to time from a conventional layer operation. So they're feeding them GMO feed, so I got GMO manure. We have activated water with your system, have you looked at how that would affect the breakdown rate of the GMO, or the Roundup in the manure because of your water compared to normal water?
Well, yes, Andy is actually working on a type of microbe to address that in combination with our water. What the water does is it brings in the natural frequency that those living things need, and the vibrational power is so powerful, coupled with what Andy is doing, and we will address glyphosate that way. And actually, this is coming up next season, a few months from now. He was in the laboratory 2 days ago and testing it, and the results were amazing. Andy, I think you should talk about it.
I'm just going to piggyback on that. From what I've seen early on in the lab, as far as getting glyphosate or any other contaminants out using the water does a pretty good job of preventing that from leaching, but it doesn't really take that out of the manure and remove it. So you have to have some sort of biological or other component to break that down. And furthermore, I'm going to piggyback on something else that was said. We really want to promote that cross-feeding and diversity of the species to improve the rate at which that's breaking down. So one of the ways that we try and do that is to introduce several other species and a comprehensive food source to encourage the other forms of bacteria and fungi that we need to be active to be active.
The other thing you have to be careful of, There are bacteria that break down glyphosate, but they break it down by producing the intermediate AMPA, which is actually worse.
Right.
So you get a worse problem. So you need bacteria that use something called the third pathway of glyphosate degradation, and that breaks down glyphosate without producing AMPA as an intermediate. Or you can, design a system that has other microbes that will break the AMPA down, but we have both glyphosate remediating organisms that use CP lyase in the circosine pathway, and then we have the third pathway that breaks it down without AMPA.
So generally speaking, I know Bob's going to chime in, but generally speaking, the more diverse the population, the better that remediation takes place. And actually the medical community did a study, I don't know if you'll mention this, but they mentioned that people that had glyphosate-related inflammation in their gut, the top 7% of people that were what they deemed the healthiest had the most diverse microgut biome. So there's a lot of research that indicates the larger that community is, the more there is a likelihood that we can address that.
In Hillman, Michigan, we have a gluten-free factory. Now, this is only a town of 500, and normally if I would go on the road, I would try to promote it, but it would be the last food I would eat. I have a patient that comes in, they dropped off all the Navy beans, because that's what they make them out of there, and they started having seizures and passing out because the Navy beans have so much Roundup in it, there was nothing but fungus and mold. So if you think that you're doing good just because you're eating gluten-free, it probably has more Roundup than oatmeal. And that really causes problems. I'm sorry, I had to say something.
Yeah, a few things going on. Art and I were over in China at a big conference. The 7 top generals in the Chinese army were in the front row of the audience, so we did not misbehave. But the whole topic was do we import or not import the grain into China? In the end, the guy that made the decision was a fellow named Wu Fepeng, who was also a Monsanto employee. They don't see anything wrong with that. But anyhow, we've been, until now, a person could inoculate their windrow of composted manure with a product called NutriSmart, which was developed by Frank Dean, who was a former chemist with Stoller Chemical. He's still down in Houston, but works independently. Dan has worked with him some, and he's developed a very good product that allows plants to take stress and heat quite a bit better. Michael is doing work with Martha's microbe, and the NutriSmart would bring 80% of the Roundup down within 12 months, which Mike was working on a project with Martha up in Wisconsin this year, and what they saw was a 90+% disappearance of glyphosate within 90 days. And they did some testing where they put another source of lactobacillus bacteria to act as a synergist or food. And you're thinking, what, maybe 30 days or 45 days, Roundup is 90+% gone? So Mike's still cranking through the data. And like I said, the guys that have bad tar spot, that's probably the #1 cause of the problem, because the minerals that are there are no longer plant available. And you cannot, the only way you can distinguish between available and unavailable is using a synchrotron. And those cost $8 billion. There's one in CERN, there's one in Long Island, and there's one in Adelaide, Australia. That's about it. Yes, Martha.
There's actually, about a month and a half ago, a paper was published on a new method for glyphosate detection that can detect glyphosate in 23 minutes, and it's using, I'm not going to get this right, but it kind of looks like a molecular trap to me, and copper is part of it. And it uses fluorescence. So I sent it to Don Huber and a couple people, but it's a new methodology, and Don says that after reading it, that sensitivity level could be increased by about 1,000%. So it would be fast and inexpensive and quick to do.
Yeah, Carol and I were working with a company called Cellcore out of Nampa, Idaho, The chief chemist was a neighbor and friend of Don Huber's. And what they were doing is they developed a series of pills called HMET, which stood for heavy metal environmental toxin. And we worked with them and worked on their conduit in agriculture. And they put some clinoptilolite in it, but if a person would send a urine sample to John Fagan at his research health lab in Fairfield, Iowa, he's got a used tripopol Cyax mass spec that would detect down to 60 part per trillion. Very fine accuracy. And what we saw, say, Kevin Kimberly had a good friend, farmed his ground, and he was having neurological problems where his body wasn't doing what his brain was telling it to. He was worried. He went to Mayo Clinic multiple times, and they couldn't come up with anything. He had his urine tested. He was at 3.6 per billion, which is 7x over safe. And he took 3 series of the Farmer Shield, which is a mixture of things, and after 3 treatments, 90 days, he was under 0.5 and all of his symptoms disappeared. But I think every farmer that sprays herbicide or is around them in a warehouse should have his urine tested every year. Now, if you ask what a cancer treatment is going to cost, is probably go through MD Anderson, you're going to pay $1.2 million, or your insurance company will. Farmer Shield was running about $270, and John Fagan, his urine sample, if you go through Carol and I, is going to run about $80. So is it worth it? And anyhow, the fellow that will be here in the morning is Alan Lindsley. He's a very good biochemist, dairy farmer kid, also mechanical engineering degree, very good human physiologist, and he is replicating those products for us, and they'll be available again this next year. Very affordable, and he wants to speed it up so you don't have to go 90 days. So if you can come back tomorrow, I think you'd love to hear him speak, and then also Martha is going to speak also. Plus Steve Applebaum is going to talk about carbon and why doing everything. Say, for example, David Hula last year before, when he raised 600 bushel corn, he only applied 300 pounds of nitrogen. The rest of it came by banding humates in furrow and having microbes in the soil that ate the humates and kicked out the nitrogen.
More questions?
This is for Dan. Can you explain a little bit more about how to release the potassium in your soil?
Well, there's a couple of situations that go on there. One is because of the presence of what we call smectites or montmorillonite type clays, they shrink and swell quite considerably. And so in many cases, as those clay particles shrink down, they actually tie up that potassium. So some of that is measurable, a lot of it isn't, just because of the conditions. So as we're looking at dry conditions currently, we may actually have more potassium tie up than normal. The other is the presence of other minerals that bear potash, like olivine. And olivine is a very common mineral in soils that came from Canada. And there are microbes that actually do produce enzymes and acids that will break olivine down and release that potassium from that mineral. So that is one or two ways that we know we can have an impact. So if it stays bone dry, then it makes the case that maybe we should put a little more on. But if it stays bone dry, what are the chances of getting a good crop? You see how this whole thing just kind of jumps on top of each other. The other thing you can do is anything that improves the porosity of the soil, that allows for you to make better root masses. Many of the microbe groups that are out here now actually produce root growth hormone production, and you dramatically improve the root masses time and time again. And so if you've got increased porosity, increased water holding capacity, and there's more moisture in the soil, what does that do to the clay? That allows for improvements. High calcium levels applied to the soil. So if you're maintaining in these soils that are CECs of 25 to 50. You need to have calcium levels probably, if you can, somewhere up in the low to mid 70s. Percentage based on your soil test, so percent base saturation of around 72 to 75%. That will allow that clay to hold moisture, allow for the clay to expand, and release that moisture back to a crop. It's the high mag soils that we really run into trouble, and especially around here if you have high magnesium and high calcium, getting potash to actually show up on the soil test is very difficult. So all of these pieces are things that we've used, and we run into a lot of trouble with the universities, for instance, when we talk about this. I mean, the whole idea of being a base saturationist puts you into a cult. I actually talked to one of the university personnel, and he started off on a tangent when I called him and asked about his potassium studies, and he was very tickled that I would ask, and he went off into this, and he's like, well, we've got to avoid these base saturations. He says they've turned soil science into some kind of cultic review. And he went on, and then at the end he said, oh, by the way, how do you recommend potash? Do you recommend it based on tri-state recommendations or base saturation? I said base saturation. Got kind of quiet on the phone because he'd already implemented me in a bad situation. But so much of it is they're so worried about the availability of the nutrient that they forget about the fact that because these elements all act differently and they hold water differently in the shell around the outside of them physically, the calcium releases water very well. Magnesium holds more water, even for its size, it holds more water than calcium does, but it won't release it. So you get wet, sloppy, nasty soil. And then you can't get the potash in there because all this calcium and magnesium is not going to give way for this little potash ion to go stick on the soil. So we've got all of these issues that are going on constantly about just trying to manage things that we don't even understand yet. So what we're trying to do is not come out here with some brand new scientific way to fix the problem. It's like, let's just manage nature as best we can with the pieces that we've got and keep it close and functional, and we'll get the results that we're after. It may not be A, B, C, D, E, but the whole point is we're after something that's very, very expensive. If they just reduce the price by 80%, would any of this even be into discussion?
What's so frustrating to me, talking about calcium, is when we do a lot of soil testing and we do a lot of fertility recommendations, but the biggest problem I have in getting what we recommend done is the retailer around here. We have a heck of a time getting lime applications made. And we have very variable soils. We have many, I don't know what the percentage would be, but I would say probably 30% of our soils in a lot of fields are low in calcium, lower than that 65 or 70%. And that should be the first thing. I've had this discussion with retailers. That should be the first thing we do when the crop gets off is get the lime applied and get them worked in. And we have a heck of a time getting that done.
Well, and I think this lends itself to be able to discuss just like what Rich was talking about this morning. As we look at all these different minerals that are necessary, sometimes the easiest and most direct way to fix the problem is with limestone, because that seems to be something we get a lot of, and it's fairly moderated price. But sadly, it opens up the world to, if we can actually just find good calcium products and products that can be banded, foliar fed, all kinds of different ways, they do help. But we have to be careful that someone's not bringing in trashy science with those products to assure us that they are available, but really they aren't. And so, as we're looking at calcium availability for the plant, we recognize that we need lots and lots of calcium to hold the sugars, make and manufacture and hold those sugars, as well as cellular strength and other things. But those are separate issues compared to what we're talking about even with the potash roof. It's a matter of clay health versus the physiology of all the pieces of the things that are going on here with the microbes and the plant. So it's a myriad of things.
Well, one avenue of soil fertility that seems to have been researched, but the research findings squelched, is that of foliar fertilization. And we've worked with a couple of companies on that. We've done a lot of work with redox. When they have questions, they've got products that work quite well. We use their silica a lot. But when they have questions, they go to the expert in the U.S., who is Patrick Brown, at UC Davis. And his latest work is suggesting there might be a separate vascular system for each of the minerals. He's still picking up on that. We had a Bulgarian fellow came here, and he went to their sister company down in Monterrey, Mexico. And so when Patrick has questions, he goes to Monterrey and talks to those guys, because they're the best. And anyhow, I kept looking for the source of foliar research that was done. Kept getting referred to Michigan State University, but their famous researcher was a fellow named Morse Vitosh, and I found out it wasn't him. Kept looking, and my wife and I were down in northeast Brazil in the states of Pernambuco and Alagoas, and one day was spent in the classroom inside. They handed me a textbook by a fellow named Euripides Malavolta, who was a famous professor considered half crazy, but all of H.B. Tookey's work was published in there, and I just had to decipher it from Portuguese and English. But what Tookey did, he was in the Heart Department at Michigan State, and he was curious about this, so working with the Atomic Energy Commission, he was able to obtain, through the Atomic Energy Commission, radioactively labeled fertilizer, and he sprayed it on woody plants, other crops, and then row crops. And after he sprayed it on, he went out, working on a 24-hour day, he went out and chopped off plant parts. An hour later, 2 hours, 3, 4, 6, 12, 8, 12, 24 hours later, and laid the plant part on an X-ray scanner, and he measured how far it moved and how fast it moved. And then he came up with ratios as far as how much more efficient was, like a pound of phosphorus was when it's foliar applied than, say, soil applied. And phosphorus was 20 to 1. Copper was 35 to 38 to 1. Potash and nitrogen, 10 to 1. So I've got some of those charts back there, but it's fully available. And we've been working with products from a German company, Phytobiotics, but more now with a company called Albion. And if you buy, my doctor said I should start taking magnesium. And I got it. Guess who's making it? The same company we get the fertilizer from, because they've got the best quality. And we're doing stuff with ounces of products that it used to take pounds of. And what they're finding out, they've got a very good chemist. We mention Don Huber quite often. Their chief chemist is Don Huber's first cousin's nephew. He was here for the Farm Progress show. And we were talking about that because we're seeing in some cases where they're very low in calcium, very low in potassium, and putting on a lot of product on a droughty soil, it's not going to get in. But if you put it on in the right pH water during a time of the day when you don't have 85-degree temps within the next few hours, and it's in the right form, and amino acid chelated, or if Drew is here, is chelated with a phosphite, it will soak into the plant in a matter of hours and go all the way through the plant shortly, totally systemically, totally curatively. And what Tracy is finding out is when they stimulate the plant and the plant cells and the plant roots to go after like calcium or potassium, they'll pull some in immediately, they'll gain from what you applied, but it'll turn the microbes on the end of the roots. The more mycorrhiza, fungi, the quicker they act, but you'll put in a lot more of that mineral than you had ever put on. Phytobiotics did a trial with Kevin Prevost down by Bloomfield, Iowa in 2020 in the Iowa State soybean trial. He put on 2 ounces of calcium per acre on a crop of corn. It bumped the yield up 22 bushel an acre. They never expected that, so that's why they're somewhat continuing this research. So consider it, but it's got to be the right form. And what I'm seeing, the amino acid chelated stuff, we put on 2 ounces of copper per acre on heavily infected corn near Cahokia, Missouri in August 20th, 2020, and we completely took out the disease starting in 30 hours, and a week later all the leaves were healed up again, and the corn stayed live for 40 to 50 days with just 2 ounces of product for less than $4 an acre.
Next question. They're down there, and they'll work their way back.
I had a question on foliars and time of day of application, and I get it, stay away from the hot part of the day. Thank you. But is it temperature? Is it sunlight? Is it time of day? What is closing that plant up? And so, in other words, can I spray all day if it's a cool, cloudy day? Or if it's a cool, sunny day? Or just don't spray from noon to 6?
I'll start that.
Why did everybody look to me?
I'll do my best to explain this. If you get the book's Mineral for the Genetic Code that Chuck and I wrote, all life on Earth is a DNA based. We have 23 chromosome pairs in our body. Energy enters our system at 4 in the morning through the action of vitamin D. At that point, our DNA coil is at the tightest coil, and it starts to expand, and it expands until 4 o'clock in the afternoon, and then when iodine hits the switch, it tightens back down. So at no minute or second during the time of the day is your DNA coil the same frequency, because it's constantly expanding and it's constantly in contraction. This gives us what's called our circadian cycles, and they are coming out with more medicine right now going, you take this pill at night, it's going to work 100 times worse. They're coming out with chemotherapy. You don't want to do this chemotherapy at certain times of day, because every mineral on the periodic table that we need regenerates at a different time of day. For example, boron is the mineral that allows you not to get burned. You get water core, you get apple scab, and yet boron regenerates at high noon when the sun is above the sky. Now, as far as plants is what time to be, I would have to divert to for the, and you're shaking your head, yes, Andy.
I think a lot of it depends on what you're trying to get in, but from a biological standpoint, from what I've seen, we have the most success at night, and I think that's predominantly because of the moisture. So it doesn't really seem, the temperature didn't really seem to impact it as long as it was warmer than 50 degrees Fahrenheit underneath that 86 mark. But the water seemed to allow it to penetrate in a little bit further into the soil and into the tissue. So biologically, I think that's why the nighttime seems to be the best, or early evening, early morning times.
I also, I'm still trying to wrap my head around everything he said today, because it's having an impact on me thinking about how tight is the gene in my plant. But it makes some sense to recognize that, a plant, when it's in those conditions, has open stomates underneath the leaf, so you have fog. That's if it's a material that's in a very steamy scenario, it can go in with the air, so it does go into the plant. The plant is also at that point typically under the least amount of stress, because it's not also using the energy itself to fight off the stresses of the day. So the maximum amount of available energy in terms of reserves would be available there, and allowing things to be moving more efficiently in the plant at that time. And so even one of the gentlemen that we worked with years ago, who was doing studies on his own, from his own company, from a foliar standpoint, he was actually using the same products that when we were talking about Frank Dean a while ago, when Bob was talking about Frank Dean, Frank had come up with some of those products. And they actually found that from 4 a.m. to 7 a.m., consistently delivered the best return on investment across the board. From 7 to 9, it was a significant drop. From 9 to 11, it was another significant drop. And at no point did they ever really get advantages at all from 12 noon to about 6 or 7 o'clock that night. And depending on the type of corn, so if it was corn, not soybeans, if it was a workhorse corn, which means it utilizes its nutrients earlier in the season, if it was a workhorse corn, their foliar treatments early in the season paid out huge. If it was a racehorse corn, they paid out huge once you got to V10, V12, or tassel. So the time of day was 4 to 7.
I was just gonna say that, when you're talking about foliar feeding in the right time of day, you should really be thinking about that when you're talking about killing a weed too. So, it gets hot and dry, and there's no moisture or humidity in the soil. That weed's gonna harden off, and you're not gonna do anything. You're throwing your chemical out the window. So no different than foliar feeding your plant.
Something that they both said, Andy and of course Dan here, about water. Okay, and that dew. When does dew typically show up? In the morning. Now, where did that dew come from, or how did it formulate? That excess energy that Dan was talking about, that plant had absorbed from sunlight during the daytime, is released at night, and as that energy is released, the dew is formed. Now, it's much like this vessel that these vases, Voss vase, that has that water in it, okay, and had ice in it earlier. In the South, everybody says about our iced tea and our love for iced tea, but our iced tea with ice in it, something that you may not have heard yet is about ice is stored energy, because it takes energy to make ice. And I ran into this situation about 10 years ago in Virginia. I had a no-till soybean farmer who was complaining about he was having to try to no-till beans into corn stubble. And for 2 years in a row, he had a real problem with that. He called his county agent. County agent came out and said, it's the lack of nitrogen. He ran out of nitrogen. And he told me that, and it really puzzled me. And I said, nitrogen, what on earth? Well, think about what is our predominant nitrogen source, NH3. We have, or NH4, we have 3 or 4 molecules of hydrogen energy tied to a nitrogen molecule. We know how dangerous and how powerful anhydrous is, and how it can burn you, and you can have serious issues with, anhydrous leaks. Well, and of course the expansion valve is under pressure to get enough gas. We have it in a liquid form under pressure in that tank, and the expansion valve, what happens? It freezes. I've seen this same thing happen. I saw a truck one day filling up at a Chick-fil-A, was filling up their carbon dioxide valve, and it was frozen because you had all this energy in that liquid in that tank, but as it expands and turns into gas, you're releasing that energy, and that is what is freezing up that valve. Well, that is the same idea or concept behind why would that glass of iced tea, as it melted, water forms on the outside of that glass. It's much like exactly what's happening in that plant at night. That dew is being formed because what is in our atmosphere right now that we're breathing? What's keeping us alive? It's not just the 21% oxygen, it's the 78% nitrogen. We've got to have both, because the amino acids and proteins that we need to reform our body and our cells that are continually degrading and dying off and rebuilding, that process is from the nitrogen that we're breathing in. And we fixate that nitrogen as long as we've got carbohydrates in our body, because if you were to fast and drink nothing but water for 3+ days, you would actually have no more urea in your urine. The urea is only there because you have the carbohydrates in your system, the food that you're eating along with the water, and then your body can fixate that nitrogen. It's no different in the plant world. Everything that's been said here about our bodies is the same in the plant world. So we observe what's happening in our bodies, much like Dan said. We've learned so much this morning from your talk about these essential nutrients and how they affect our body, but it's so important that we look at the balance of everything.
So are the plant mitochondria making metabolic water like people do, and that's part of the dew?
Absolutely. I really, absolutely 100% believe that, because what about you go out at night, you're just out at your farm, and you go to a gate, a metal gate, that it heated up during the day, and what are you going to feel at night? It's going to be wet. There's actually moisture on top of that metal gate. It actually made its own water.
Condensation, though.
The condensation.
That's different than respiration.
But
Yeah. And on the application foliarly, or just any surface, any time between the hours of 10 and 2 is the most intense ultraviolet spectrum. At which point, since we're dealing with the biology and not a technology, it's alive, we don't want to use ultraviolets to pasteurize or sterilize or anything else. That's the stuff we're trying to keep alive. And so if you're doing it in the morning, you have a smaller window before your peak solar radiation period. If you do it later in the afternoon, you have the maximum of time prior to, which allows the amount of time the creatures need to move around, find protection, get inside the stone, all those different things that you're trying to accomplish. because it's alive, we don't want to kill it.
George talks about dew, and it comes out in the morning, right, George? Dew is not H2O, it's D2O, deuterium dioxide. And the planes that have been flying over have changed the atmosphere so much that the bacteria that triggers the cloud formation is letting dew go up high enough into the clouds, and it is now snowing at 34, 35, 36, and 37 degrees because that's the freezing temperature of deuterium. When deuterium comes down, it's that wet, slippery stuff that you think will break your barn, and it has different electrostatic properties, and it'll sit on a telephone line and go 6 inches deep and bend almost to the ground. It's happening all around us all the time. When it snows in Texas and they make snowballs and they put a cigarette lighter underneath it and it collects carbon, that is not H2O. The organic farmers are adapting to this, but the conventional farmers are going to get more mucked and more mucked because they don't understand that dew is no longer coming up 3 foot early in the morning and going down when the ultraviolet rays hit it. It's become a natural phenomenon, and we're now having snowstorms that can be generated from the aircraft and the G5 towers that will direct the energy. Now, you have a book called The Fourth Phase of Water, and this guy is showing, I wrote him a letter, I said, is this deuterium? He says, I don't have any idea. Maybe Vatche can shed more light.
The fourth phase?
The fourth phase of water.
Dr. Pollock?
Yeah.
I don't know what to tell you. So many stories, so many books, and George talked about ice, about Georgia, and all of that. I say, okay, good. I put ice on my scotch. Well, but ice is dangerous. Never drink water with ice. I don't care your iced tea or you're in Zimbabwe, never do that. Water should be taken in room temperature. Also, I hear about deuterium. That's heavy water. Lots of people talk about it lately. And as a matter of fact, Pepsi Cola called me just 2 weeks ago asking me about this. I hear all those fancy words. And I haven't heard alkaline water here either, and I hear the science behind it, and I sometimes wonder, do those scientists know something that God doesn't know about? I don't get all those fancy words you guys been using. Water have a certain frequency. You mess with it with temperature, because water have its natural ambient temperature that creates. You mess with it, I'm telling you, it's gonna mess with you. I give a speech at, what is that fancy, in Minnesota, fancy hospital? Yeah, that's the one. A piece of shit doctors there. After I'm done with that, he called me and he said, Vatche, we need your help. I said, I stopped him. I said, don't call me Vatche next time. I never ever use my title. I says, use doctor. Have you seen Jesse Chase, the doctors? Doctors. You saw that movie? I played the same game. And I said, what do you need? He says, we have 32 patients, we can't figure them out. Do you mind if we take a look at them? I says, yes. I went to them. And one of them, she was a lady about 63 years old. I looked at her, I says, ma'am, do you have cake and water? She says, yeah, for 15 years, and I love it. I looked at the doctor, I said, that's the problem. You and your first fancy words about water. Water should be simple. None of those. When you talk about 4 phases of water, come next year, you're gonna have somebody talking about 8 phases of water. It's just simple. Water have a frequency. You mess with its frequency, it's gonna mess with you. Because that's the only thing that knows your organ frequencies. What do you think you are? Most of you is liquid. So, stop, in a way, getting romantic to try to impress each other with fancy words. Water should be simple. room temperature, and stop fooling around with it. That's it.
At 4 o'clock in the afternoon, iodine is regenerating, but so is fluoride. And iodine covers you for fluoride. At 7 a.m., when selenium is regenerating, that's when deuterium regenerates, and that's the mineral that protects you from deuterium.
Well, so actually, I'll talk a little bit about this tomorrow, but the probiotic that we ended up making that's a working system on the human side, we made to convert glucose and fructose into mannitol in the gut, because mannitol was shown to stop the aggregation of the proteins involved in Parkinson's. I got into this because my husband's Parkinson's. Well, so if you go into a fermentation facility where they're making protein, they want a more acidic environment creates more protein. So we designed a system to convert those sugars into mannitol. It modulates pH, so you get, like you want your water, you want, the human body should be kind of a neutral pH. So you constantly have this problem going on. So then I went back looking in plants about mannitol and this endogenous production of mannitol, because plants use mannitol to manage osmotic stress. So on the human side, they think, mannitol is just an osmotic diuretic, but I think it's the same as in plants. It's actually an osmoregulator. And so I actually want to ask, I don't know if I can call you Vatche, but so there's a couple things. When you endogenously convert those sugars in the gut, you're picking up 6 hydrogens in that molecule and taking it out in the poop. So you could be removing deuterium, but we don't have to get into that bullshit if you want. But I've been looking at water and water homeostasis in the body and the cerebrospinal fluid, because in Parkinson's, so I started out I'm the poop queen. I started out when I got interested in the microbiome, I was like, well, the answers are in the poop, so we designed a kit to collect a standardized poop sample, make it available to all these other scientists, do sequencing, look at it. But pretty simple. The 2 young women who worked in my laboratory who processed all the poop, I was interested in Parkinson's, so we had a lot more people with Parkinson's. And after a while, they came to me and they said, you know what? We can tell somebody has Parkinson's just by looking at their poop. It has the consistency of concrete. So we process those samples into little aliquots that scientists could use and we could use. But the Parkinson's samples, we couldn't use a syringe. We actually had to use a caulk gun, because there's a problem with water homeostasis that I've been trying to figure out, what the hell is going on? So I want to ask you, but you probably can't answer that right now. But, back to mannitol being an osmoregulator, I designed the product originally for my husband to make mannitol to stop the aggregation of the proteins. But it turns out, it addresses glucose metabolism, insulin resistance, glycolysis, like all these things that are wrong in the system. This little working sugar conversion factory is fixing that with mannitol. So then if you want to go back to God, what did they eat in the desert? Manna. Well, that's where the word mannitol comes from. So I don't know, that may sound kind of crazy, but that's sort of my question about water and mannitol and mannitol in the plants and the, respiration that you're seeing in the dew. All of that ties back to metabolic water, which is in the mitochondria, which I could go on there too, because that is living water.
Well said.
Well, where does water come from? Where does our rain come from? Where does the snow come from? And if you go, there's one of the favorite things that I like, you can go in the scripture, and the rain and the snow come down from heaven and shall not return them. There's a point to that, much like God said about his word. It goes out from his mouth, and it accomplishes what he sent it for to accomplish. The same thing is with the rain and the snow come down from heaven and shall not return there, but provide water seed for the sower and bread for the eater. Okay, so this is scripture, but the point is that water, we know we have transitory evaporation, but yet spiritually again, I don't know, I'm going to share this with you, Genesis 1, the creation story. First there was light, God created light, but then he separated the waters from the waters, and he put half of the waters above the firmament and half of the waters below the firmament, and he called the firmament heaven. And then he created the landmass in the waters below the firmament. That is scripture, Genesis 1. Now, I read that thousands of times and had that read to me thousands of times as a child in the South. And of course, I was Southern Baptist raised, okay? And everybody says, well, what is a Southern Baptist? They asked me that in California, and I said, well, we're the ones that have to have fried chicken after church on Sunday, okay? That's what a Southern Baptist is. But the point is that I didn't have this revelation until I was ready for that. But that actually came out of Ezekiel 55 and then to Genesis 1. The revelation of the water was split, and there was half of the water put above heaven. Now, the point is, okay, in days gone by, I hate to say it, but 40 years ago, I was a Navy jet pilot, and I flew off aircraft carriers all around the world. And I was up at 50,000 foot going faster than the speed of sound. But yet, it's very cold up there. It's wicked cold, okay? So what is the largest component of our entire universe? It's hydrogen, hydrogen energy. Our sun is a ball of hydrogen and shooting off hydrogen flares. So all of this hydrogen is energy out in space, and it's super cold. And what is a comet? They say a comet is an ice ball that's flying through the atmosphere, picking up all this energy through space. But what happens when it hits our atmosphere? It explodes. It sets on fire. How can a ball of ice turn to fire? But it's just like we were talking about earlier. You've got all that energy, but what do you need to have a fire? How do you put out certain fires, a grease fire? You smother it. You take away the oxygen. You can't put water on a grease fire. There's a reason, because you've got to shut down the oxygen. So again, this is all about balance, our whole life and everything we're doing. And unfortunately, I very sincerely believe, and I won't belabor it, but in my lifetime since World War II, and I'm 67, but in the last 77 years, my greatest testament of why I got on this carbon track is there's the oldest living citrus grower in the state of Florida. His name is Gilbert Bowen. Mr. Bowen's 93 years old. He grew up in the 30s with his dad and his granddad. They only had 4 items in their entire agronomy program prior to World War II. They planted the trees 60 foot apart. They planted a cover crop, which just happened to be either alfalfa or clover. Why would you plant a legume? Nitrogen fixating. They didn't have ammonium nitrate. They didn't have anhydrous. They didn't have calcium nitrate. The second item they had was sulfur dust as an insecticide. They had copper powder as a fungicide, which has been around for 10,000 years. It's the greatest fungicide on earth, but copper's not selective. It kills everybody. It's like penicillin, wipes out everybody, good and bad. And then they had citrus spray oil, which was petroleum-based. That was their entire agronomy program before World War II. And what he told me one day about 15 years ago, he said, George, you're on the right track with this carbon. He's saying, after World War II, they came to us with all these new things. One of them was anhydrous, and then it became ammonium nitrate, and then it became herbicides and fungicides and bacticides. And he said to me, he said, what do those all have in common with the CIDE part? With insecticides, bacticides, fungicides. CIDE is death. So literally, since World War II, we've been farming with death. And it works to a point. But the point is of all of this is that we went too far away from the natural way it works, and we've added all these man-made things to try to overcome Mother Nature, which we will never succeed. It's not when we will fail, it is literally. It's not if, it's when. We are going to fail. So this is a great gathering here and a great opportunity to share that we're trying to now look at the ability to reverse some of this damage that has happened over many years. But I always say, look, the bad stuff happens overnight. The good stuff's going to take longer. It didn't break this overnight, and we're not going to fix it overnight. It's a program. And everything and everyone here together all these different puzzle pieces that you've heard about today, when we put those together, that's when we get the solution. The synergy of all of these things together is what really works.
Questions?
So it's a little intimidating to be sitting amongst all these scientists and doctors around here. But for my question, after Vatche's presentation today, I saw him in the hall and he says, "How was the presentation?" I said, "Well, the first speaker was really good." And so anyway. So Vatche and I like to kind of spar back and forth. I sit on a couple soybean boards. One is on human utilization and stuff. And the government mandates that are coming out for the increase in the biofuels and the SAF, the airline fuels and stuff, there's going to be an abundance amount of soybean meal. That's going to be the byproduct bottleneck, challenge to overcome. And there is some NPK value in soybean meal, and I'm just wondering if there's any way between all the mines that are here and the biological products and the new technology, is there a way to increase that value of that soybean meal and really kind of close the loop of maybe providing that fertility back in a very geographical region, especially with all the challenges we have currently with fertilizer. So without any additional, comments, I just wanted to throw that out there because that is a challenge. I spoke at a conference last week, and my comment back to one of the large grain companies is that to get rid of it, we're going to have to lower price, and then we will be charged with an anti-dumping type lawsuit or trade imbalance or not trading fairly.
Market fixing.
Yeah. So anyway, so if there's a way to increase that, because that will become a resource very quickly, and the mandates are are certainly supported by both sides. So.
Who's going to jump on that? Are you going to comment on that? Well, that's a good question, a good point. I think one of the things, and I have not done homework on soy meal. I mean, I don't know the ins and outs, but I know I've done it with sugar. I stopped when I was at the Commodity Classic one time years ago, and I stopped at the sugar booth. And I asked the guy at the sugar booth, I said, "What are you doing about providing sugar to American agriculture?" "What?" "Well, you can go buy it." I'm like, "You don't have any idea what I'm talking about, do you?" Because I said, we can go out and put 1 pound several times on corn, soybeans, wheat, alfalfa, any crop, and dramatically improve its ability to function. And he said, "Well, we can't produce more sugar because it's a problem internationally." And I said, "So why don't you denature it? Why don't you make it unconsumable by human consumption so that now you can actually provide several pounds to several million acres of crops each and every year. So one farmer can produce a product for another farmer to be more productive. Why don't you do that? And that's going to change the way we see the world." His eyes got about as big around as $50. He says, I got to make a phone call on this. I want to have somebody call you. I said, "Well, that'd be fine." Now, I walked away thinking, I hope they do call me. And then I said, even if they do, I'm not going to answer the phone. It's funny because I'm like, if you're not that smart to figure some of these things out and you can't do this on your own, am I really talking to the right person here? But your point's a good one. How can we alter protein or amino acids or organic materials that are readily absorbed by the cuticle of a plant and possibly transfer or make a new product that makes a foliar product better? For years, we've put sugars into foliars. When your question a while ago about how efficient you are on time, the time of day, it also depends on how that product's formulated. And if that product of soy meal if we can figure out something to do with its solubility, because oftentimes I think soy meal might be a little more challenging to work with as a carbon material, but still can be done. I think it's a good idea to explore that, because if indeed it does dramatically improve the uptake characteristics of foliar materials, because that's really what it's all about, is you've got to get it across that cuticle, you got to get that waxy layer, you've got to wipe that waxy layer off and get it onto the cells, which is dangerous, because take the waxy layer off and keeps the plant from, the plant will actually lose moisture because it's not covered properly. Or penetrate it, and once it goes through that, whatever's dissolved in that foliar material is coming into that plant like a rocket. Throw a little sugar in there with it, and you might have magic, because now you got carbohydrates and proteins. And what? Oh yeah, and glyphosate.
It is, but through the heating process of most of these plants, that protein is killed, from what I'm told.
I hope so.
So, but you know, but you're talking about turning it into a liquid or a foliar, and I'm just, you know, that becomes very expensive. And so, is there a way to granulize this, or keep it in the solid form, use it as a starter, or as a, you know, in furrow, or as a you know, as a fertilizer to spread?
Oh, I'm sure there is. I mean, that's just a matter of, that should be one of the next things that we should have as a PhD program, rather than trying to figure out for the 975th time how to try to get more P and K into a plant. All right? And I think you could be onto something, because soy in and of itself has a lot of unique characteristics that people have discovered through the years. I mean, you know, we're burning it in candles. You know, we have it all kinds of places. It's got a really good value to it. I'm encouraging you to keep pushing, because I think there may be something there that's going to be extremely valuable. And we've got to figure out something to do with all this soy. We're not feeding it anymore, or it's got all this other stuff with it that we don't like. We've got to figure out some way to utilize it. About the only thing we do is put it to the soil, let the soil degrade it, turn it into good, valuable materials for the crops. And they represent really, really good things. You know, the comment about the mannitol, and you see some of the enzyme companies now are providing, you know, mannase or mannitase for the enzyme to make more mannitol, for the reasons that Martha just explained there. We've got all of this technology, and we have to figure out ways to provide more foods to plants. We have this idea that for whatever reason, since plants make their own food, that they're fully capable of just making these massive, massive yields without food. Have you ever seen anything that eats that doesn't get hungry? That's alive? It continues to eat. We just think, well, they're capable of doing all this on their own without any other input. We're just giving them all these little nutrient supplements, and they can make enough food to make a 600 bushel corn crop. It does not work that way.
Kurt, can I add one thing? I'm sorry, Kurt. I went to school in Japan, and I go there like zillion times. Japanese, they make a product called natto, which I'm sure you're familiar with. So I know natto, which is in Ito, and I've been there, and I asked them, why you don't increase your purchases of soy from the United States? And he said, we love America, but there is something wrong with the brain of American farmers and research. I said, what do you mean? He says, we Japanese don't like artificial stuff. And I said, I didn't understand. What he meant to say is GMO and the use of Roundup. If we don't use Roundup, we don't use GMO, we have literally over 18 countries that would buy our soy in a heartbeat. So actually, the problem is with us, not with the buyers. There is plenty of buyers. Japan will be #1, Korea, North and South, and so on. So if we change our habits from GMO, that will increase our output into exporting.
The comment I want to make is, well, actually, we export natto to both Japan and Korea, non-GMO. So the Red River Valley of Minnesota, North Dakota supplies about 80% of all the natto that Japan uses. Wow. So, but Dan, to your point, the people that I would talk to about this think it's a stupid idea. And it's people at this level or in this type of setting that probably has the capabilities and the creativeness to move it forward. And you know, when you talk to industry, you know, they're still on the MPK. They're still, you know, very corporate. So that's why I brought it up here. Is that I think this is kind of the format for the minds that can move something like that forward.
I think, I'm sorry.
One thing I'm wondering is, being we're in Webster City, and we are the largest indoor fish raising facility of great tasting fish, why can't we get some legislative and industry support for using non-GMO soybean meal in fish farms? Because this country is severely deficient in fisheries and fish as a food source. That fish tasted absolutely great. And now it's tough to find except for one store in Iowa.
Questions? The tobacco industry, and I'm glad this isn't a West Virginia Tobacco Growers Association, because I run out. They had to find something they could put into a cigarette because the cigarette industry is losing so many customers on a daily basis. They had to find something that was legal and highly addictive, so they added sugar to cigarettes.
Wow. McDonald's French fries, same thing.
Questions?
Yes, we've looked at soil or tissue tests. Now, do tissue tests analysis change from the hour of the day, like you illustrated? Our bodies change and make different elements throughout the day?
Okay, the question is tissue testing. If you talk about allergy testing, since I'm on the human side, and I don't know if you're going to take the sap at 9 in the morning and have it be different at 9 at night, I'm assuming so. But if you have a grandchild, since most of you guys look like you might have grandchildren as opposed to children, you test them at 9 o'clock in the morning and they'll have a bunch of stuff that's reactive, and you can check them at 3 in the afternoon and they're not reactive. This is very true, that times of day will make a difference. You know, they might be allergic to 153 things at 10 in the morning when their allergies are bad, but come the afternoon, when they're doing better, they're really not testing for the antigens. It just depends on what cycle the body is going through the regeneration and if it's successfully regenerating at that time of the day. Now, the young lady that is not sitting here anymore talked about mannitol. And mannitol, and she linked it to fructose. And I link it to boron. Because what's the difference between humans' physiology and plant physiology is plants have 2 cell walls and humans have 1. And the outer cell wall that gives a plant its structure is pectin and boron. That makes a bunch of real nice cross links, and it causes the plants to be upright. But what in the human body has a double cell wall? And that's the mitochondria. And her question is the mitochondria. And she has a husband with Parkinson's. And they know that there are 2 bacteria missing in the gut of a person that has Parkinson's that's no longer making PARC. PARC is a chemical that makes your body have hand-eye coordination. And by the time you realize that you're losing control, you've lost so many cells you may not be able to grow them back, and everybody's just trying to stop it. Mannitol and fructose belong to a classification, and I'm sure all you chemists will understand this, of something called cis-diol, C-I-S-D-I-O-L. And this is a direct link to boron, and then you have a few other chemicals that are cis-diol flavonoids, like rutin and resveratrol, and there's a handful of them that are all part of the polyphenols, and I'm sure you understand all this stuff. But this is linked back to boron, and boron deficiency, you lose control of mannitol, you lose control of fructose. And they make a product called calcium fructoborate that's prostate specific and breast specific. Questions?
That one was a little bit over my head, and I don't want to change gears because it is, but I had one that was cooking from earlier on Vatche's comment with knowing we have buyers, knowing we have the ability to go back to the old ways, if we will, of the non-GMO herbicides and things. And I guess my wife asked me the other day, she says, coming from a non-farm background, well, why don't we just stop using Roundup altogether? Well, that's simple, but we may collapse if we, Roundup or Liberty or whatever these newer GMOs. So without having this the disconnect of the buyers, if we can't find a way to disconnect the Bungys, the Cargills, the Tysons, I guess soft America needs to stand up to think, folks like this and find another way. You know, do we do like the Netherlands and, you know, we don't want to stop the interstates, but do we hold on to our grain and, you know, can we financially, most farmers can't, you know, we're slaves to our banker and, you know, personally, I mean, I am. But where do we draw that line and say, to hell with the banks, to hell with you the buyers that we have now, and how do we make that transition as growers?
Wow. Wow.
That's a loaded question.
Free market rules.
It is.
Man.
And here's where we get down to science versus sociology. Why did we want Roundup in the first place? Well, yeah, we did, huh?
Quick, cheap, and easy.
Quick, cheap, and easy. It got rid of what? It got rid of weeds. And we did it with a chemical. And for the first time, when I was a young boy, my hands were all green all summer from pulling weeds in the field. In 1972 to 76, we were growing 30-inch row beans with weeds everywhere that we'd pull every once in a while. And we didn't have any trouble growing 60-plus bushel averages in 30-inch rows in the 1970s. And then we came out with this technology that cleaned up every weed because we knew weeds were bad. And we had to get rid of weeds. Now, we had weeds everywhere. And we knew a little bit of problems with weeds. But once we got rid of all the weeds, what did the average of soybeans do? Some of it came up because guys were only making 45 or 50. But most guys, for years, were stuck at 55 bushel average. So was it the weeds? No. So we get rid of the weeds. The number one thing that Roundup allowed us to do was to do what? Get rid of the weeds first, but then what happened to the farms and the farm sizes? Oh my goodness. Now we've got the genetics to be able to farm 10,000 acres. And then once we actually farm 10,000 acres, we've got to keep those 10,000 acres. So now we've got social pressure driving us that, my gosh, if we do anything wrong and let a weed come up, the neighbor's going to offer $10 more an acre, and he'll say, I'll never let those weeds show up. The consumers don't want it. They'll tell you clearly. A little bit of information goes a long way. We don't really want that stuff. Why do you use it? Because of social pressure. From who? Our own people. It's a situation that, can it be done? Yes. Can it be done successfully? Yes. Do we have to have the maximum economic yield on every acre? Well, it sure would feel right. But does it allow for it? No, because the people who use the Roundup didn't even know how to use it because no one ever told them. If you spray Roundup in the middle of the season, it always moves to the most rapidly developing tissue. Well, in a soybean plant in the middle of summer, where's the most rapidly developing tissue? At a flower and a pod. And when you sprayed it, if it overloaded it, guess what happened to the flower and the pod? It fell off. Information is readily available on all this. The question is frustrating because it's like, if we actually look at the avalanche of data that came to us, we wouldn't even use the stuff. But we do because we can't seem to get rid of it because it's allowed for all of this stuff. And when we go to dicamba beans and list beans and all the other stuff, all we're doing is taking our eye off of that one and moving it to this one. If I was a hog, I wouldn't eat that crap. I can't say one way or the other. I mean, maybe that's why they squeal all the time. Get this stuff out of here. It's a sick, sick situation. I'm not saying I've got an answer, but these are the debates and the issues that we need to have with people to help them understand that it's got to go.
If you own a cancer center, Roundup is a cash cow. Ivan comes to me and he says, I've got lymphoma. I get him checked out at stage 4. I send him to Cancer Centers of America. He comes back. I said, what'd they say? I got stage 4. They're going to do all these wonderful things. I said, why'd you get it? He goes, oh, they're stumped. Stumped. In 30 seconds, I pulled up 5 articles that says Roundup causes lymphoma, and he stood there and he goes, I've stirred more Roundup than anybody in the state of Michigan. I said, yeah, well, you got stage 4 lymphoma to prove it. He's still alive.
So along those same lines, farmers like me try to reduce the use of Roundup, but you replace it with a different chemistry. Is that any better? and the research just isn't done yet, or?
Is our good friend Don Huber said for years, and he actually changed his point of view once he learned a little bit more about it later. Roundup, if it had been used as a tool, might have been of value to us if we could have restrained ourselves. But what did it become? A crutch. And we got so carried away with it to do the things that we needed to do that it ruined itself because we allowed that to happen. When we shift our gaze, the reason why these other technologies came along besides monopoly is because when the Roundup now was weakened on trying to keep some of the weeds out, we had these other little technologies waiting in the wind that actually took our gaze off of that one and put it onto this one. And I actually asked some people, what happens if you get resistance to dicamba? Well, that's probably going to happen. Why? Because we're going to use it just like we did Roundup. And then, how are you going to kill the weeds? Well, they'll come up with another new herbicide by then. So we see what we've done to the agricultural managers of this country. Not necessarily farmers. Everybody that has a farm is a farmer, by definition, if you do anything with it. But we've become managers of the mayhem, and we are all about death. It's just like George said. We are natural-born killers now. We don't want anything alive out there except our crop, and that is not natural. But that's what we've decided that we needed to do. And so, will it change? In the short term, I don't think so, unless something really dramatic happens, and if that happens, we don't know what the outcome's going to be.
And I don't know if anyone up on the panel knows that, but are the other chemicals any better than glyphosate?
They aren't as broad spectrum of chelators. That's the problem. But basically, most politicians, every university, every medical group, a lot of consumer, well, they became prostitutes. They took the money.
Somebody actually said something pretty interesting here about what we think about, we forget about dicamba. What was it?
Well, it's not just killing weeds, it's killing trees and insects and oak trees especially. And we worry about it volatilizing and drifting 1.5 miles, 2 miles away. What about when you're sitting in your living room and you got your windows open? Are you breathing that in?
And you're rocking your grandchild on your lap. You hope to.
I'm not a farmer. I'm no way near farming. I just want to, I'm falling asleep, to be honest with you. I need to say something else. Instead of using manure, well, before I talk about the manure, I learned this from Andy. He says, whenever you see wheat, that means the land is giving you a message. And the message is, the land is saying, I need help. And that's what Andy and I are doing, is try to solve it where we can help the soil. What other chemicals? How about no chemicals? How about that? The other thing I want to talk about, I'm ready for a drink. The other thing I want to talk about is why you talk about manure when we have Georgia stuff, but we have another solution for manure. Don't worry about it. Manure is the podium that Democrats stands and took. That's it.
Yeah, Vatche skipped his afternoon nap, as you can tell. I appreciate some comments, George, Dan, Andy, and Vatche. All four of you mentioned a systems approach. And I want to tell you from experience the last 5 or 6 years, working with biological nutrition, very, very complex, but yet very simple. One of the quotes that I read from a book is, what's really missing from our soil comes from the sea. All these different minerals, all these different fungal components that feed the mycorrhizal fungi and other kinds of fungal tissues. That is very important, and enzymes. And when you start going down the road into the biological nutrition, it's a whole system, guys. It's not a product, but not only you're getting the benefits of nutrients and the enzymes in it, but you're getting fungicidal and insecticidal properties in there. You're getting chitosan, so you're getting a more complex system. And I will tell you, the people that's been with me for 3 years, some of them's quit using herbicides altogether. And that's a pretty broad statement that you can do that, but you gotta stick with the system. You're not gonna go from bitty basketball to varsity in just 1 year, guys.
Did they incorporate cover crops with that system?
Yes, I mean, it's a big system. Yeah, cover crops is part of that.
Somebody else have something back here?
I have a question, and maybe Mark just answered it, but as a producer, you know, what's the trade-off? I mean, you either use chemicals for weed control, or you've got organic. Those seem to be on both ends of the spectrum. To do full width tillage on all this, then we're gonna have massive erosion issues. You're gonna put more carbon in the atmosphere. You know, I realize cover crops are part of that, but for the most part, to do much productive agriculture, it's hard to do that without herbicides or a lot of tillage. You got one, it's like the devil in the blue sea. What's the answer? And are there any safe chemicals to use for herbicides to make that transition? I don't know what the answer is.
So maybe not so much safe chemicals, but he talked about how long is dicamba going to last? How long did Roundup last? Maybe all stems with how we treat our water for our chemistry to work, what we're using for an adjuvant to help the performance of our chemistry. So, you know, there is no silver bullet, but some of the herbicides that we have out there, of course, they're all bad, but they could last longer than what they do versus, you know, around here, Liberty, the guys went from using one shot to around here they have to do it twice now. In a very, very short period of time. So a lot of it has to do with how we can correct the pH of our water. So, you know, glyphosate's optimal pH range is around 3 to 3.2. If we have a pH water of 7.5 to 8, which most of us do in Iowa, 3 pounds of AMS isn't getting you there. In fact, it would take you 11 pounds of AMS if you could get it into solution per acre to drop the pH of your water 0.5 point.
I think the reality of the situation with the pesticides is, I don't see them just disappearing. I think the point that we have to understand is we have to pay attention to all of these little pieces, and that makes it challenging for us. But when we do, wonderful things happen. I mean, I had some guys here in the last couple of years who have been saying, well, you know, the weeds are just completely resistant to glyphosate, and that's not necessarily totally true, because we have some that are very, very tolerant, and they look like they're resistant. But, you know, when we went in there and put a full pint of really good high-quality fulvic acid and sprayed glyphosate with it, it turned glyphosate into almost paraquat. A matter of a couple of days, and these weeds were dead. They hadn't seen that kind, because what their tolerance is they're building up this ability to keep the glyphosate to go to the active sites and kill that plant fast. So the longer they can keep it away in concentration, they can survive the chemical. But when you put the fulvic acid in there, because it cut the cuticle and drove everything so fast into that plant, all that Roundup went where it was supposed to go for the first time in years, and bam, just like that, those weeds were gone. So we have got to come up with systems that allow us to do, in some cases, the foliar products are nice, because, I mean, the herbicides as a foliar, the post-type products, because if we can get the water correct, we can put very, very small amounts on there and get the weeds to go. When I first started back with glyphosate 20 plus years ago with some people, we had their rates down to 6 to 8 ounces per acre and killing weeds deader than a doornail. And the number one problem with that was the Monsanto rep, because he came to that grower and said, "You've got to stop this. You are the source of our resistance." Now, he uses 6 ounces with all the materials to augment his water, and he didn't even, that was before Vatche's water was here. Think what that will do. It's all additive. But he told him if he did not raise his rate and start using ammonium sulfate, that he would make sure that every supplier in the area would never sell him another gallon of Roundup, because he was the source of the resistance. Now I asked the guys, it was Donnie was in, I said, Donnie, I said, do you believe that? He says, I don't, but he says, I don't have anything to fight with. I said, yes you do, it's just common sense. A dead man tells no tales. A dead weed makes no seed. Resistant problems are right down the road when your neighbor has to use a quart or a quart and a half because his water is so bad. And with that quart and a quart and a half, the weed doesn't die. If the weed doesn't die and it tolerates it and it makes seeds, the seeds move forward. That's your defense. You kill all weeds with your product, you're getting more in with 6 ounces than the neighbor can with a quart or quart and a half. That's your defense. And I said, the other thing is go buy some ammonium sulfate and put it in the corner of the barn. And that 6 bags of ammonium sulfate sat there for 6 years and never got used. And that shut the guy up. Is that right? No. It's not right that somebody can threaten to keep you from getting your stuff because you're smarter than the average duck. But that's the game that some people have to play. So I think what we're going to do is we're not going to see these disappear. I'd love to see it, unless we can come up with some. I mean, I know when Bob met who had the product from Australia, the foliar product, Howard. Maybe Howard's here. Howard, are you here? No. Okay, but anyway, Howard had some. Oh, he's at Acres this week. Good products that are, in some cases naturally derived and would not be a bad pesticide product to use. And we have some of those that can fit in. Are they available yet in large quantities and they're perfected? No. But little by little, they're going to get better. And we're going to have new technologies coming to us because there are a lot of bright people, just like ourselves, sitting here saying, we've got to figure out things to figure out this mess. We have to step up and we have to get it done. And it may not be perfect yet, but we've got to move things in the right direction. Was everything perfect with cover crops when you first started? No. Everything gets perfected, and I think that's where we're headed. There is no solid answer yet, but we're moving in the right direction.
As I see it, the big companies are now the Titanic. The small companies are innovative, and it's probably going to come from them. I got a chance to spend some time with a biological engineer from Australia. He said they've got all the insects and all the disease problems figured out biologically. They've got water hemp dead. They found a fungus that will kill it, natural fungus. And EPA is keeping it out at this point yet. So we need some help getting things like that in. And we probably need some funding from the groups, producer groups, to further products like that. But it's going to take someone from out of left field. You've heard Martha here, really sharp. She's probably going to put a lot of medical universities to shame if she's truly successful with it. They don't have the big budgets, but they got the brains, and they got the drive and the willingness to do it.
I want to make a couple of comments on this water thing here. Talking about pH and oxygen. I've traveled basically the whole northwest quarter of Iowa testing water in the last couple of years, looking at pH and oxygen. Little handheld meter you can buy on the internet for $300-400. And quite often the pH and oxygen are all pretty well similar everywhere I go. pH is all 7.5 to 8.5. Oxygen's negative 50 to 200. Everybody's is the same. But what's different is the amount of I'm going to say adjuvant, we're testing replenish, but the amount of replenish it takes to correct that water. And so when we start seeing differences in herbicide performance, how many of you know the pH and oxygen of your water? In this group there may be some, but the vast majority of people don't have a clue. And I didn't up until a couple years ago, so I'm no different than anybody else. But if you don't know the pH and oxygen of your water, trying to get the performance of the herbicides to work you're already on an uphill battle.
So then let's look at the biology for a minute. George alluded to this earlier, but if we sucked all the air out of this room, how long are we all going to survive? 3 minutes. You go putting a bunch of bugs in 1,000 gallons of water with a negative oxygen level, how long do we expect those bugs to survive? And then we wonder why there's inconsistencies in performance in biological products. So I guess keep those things in mind as we're working through some of this.
A lot of the co-ops don't even bother using a Vatche system or whatever, and they're using the same water you're talking about, for individuals.
I would like to express that when you're dealing with applying glyphosate, and if it's part of your management program, you wean yourself off that addiction or whatever it might be, that's also an opportunity for you to add back those trace elements that product is chelating. This is part of, if you're going to use it, that awareness that you have then allows you to put back what you took out so that it can still be part of that systems approach. And connected to, there's just some, the biology is if your water is less than 6 parts per million of oxygen, it's anaerobic. Like this is where for it to be an aerobic water to support the biology in that fluid medium, it needs to be above 6 parts per million. So if it's negative 50, yeah, it died. It's suffocated.
How do we get it there? On a farm level or a spray level? How do we get
I
it?
didn't see him, but he didn't talk about the increase of oxygen in his system. It does. I would assume it does, but yeah, that's excellent.
Sandy could answer that. In talking about the oxygen, and I like to keep this real simple, the idea about the importance of oxygen, I actually stumbled upon that from the USGS, United States Geological Service. And what they were studying why were there fish kills in the summer in ponds, and why were the fish, literally floating in the top of the pond in the summer? Well, it was the lack of oxygen, because as the water warmed up, there was less oxygen in the upper portion of the water, and there was only so many fish could be down deep where the oxygen was. So literally, that's what gave me the idea of the importance of the oxygen in the water. Now, something that we have had happen with our, again, immigration of, a lot of people in Florida, now the third most populous state in the nation. 10 years ago, the state of Florida enacted a law, they called it the Urban Turf Rule. And from May until October every year, you cannot apply any dry fertilizer anywhere along the coastline of Florida. The reason was that what was happening, the dry granules, along comes our summer thunderstorms. Even without a hurricane or tropical storm, we get 50+ inches of rain in the summer in Florida from thunderstorms. So what was happening, the big afternoon rain comes, you can almost set your watch at 5 o'clock in the afternoon in the summer in Florida, you're going to have a thunderstorm. And as that thunderstorm releases all that moisture very quickly, anywhere from 1/2 inch to 5 inches you can get in 30 minutes, all of that fertilizer was sheet flowing out into the canal, and then into the bay, and then into the Gulf of Mexico. So what happened? We have this nutrient loading that is increasing the biological activity, and the algae grows. So the algae is a great food source for these biologicals, a lot of food there. But the biology don't know how to turn off the on-off switch. They just eat till they're dead. Well, they eat till they're dead because they run out of oxygen. So then you have hypoxia in the water, and everything in the water dies. This is what causes red tide in Florida in the summertime. And this exact same thing happens. It's been well documented. This happens every spring. In the spring thaw, everything that runs down the Mississippi that ran off of every farm winds up in the Gulf of Mexico, and there's an 88 square mile dead zone every spring in the Gulf of Mexico that kind of floats over toward Florida due to the current. So this is something that's real, and it was not this nutrient loading. It's the cause initially, but it's the lack of oxygen is what actually kills everything. So again, this is the importance. Now, one other thing that has not been said today that I wanted to ask you, who who here is aware, or would there be any differentiation in the carbon needs between bacteria and fungi? Do you think that bacteria or fungi would need more carbon in their diet? Absolutely, Larry, fungi. Fungi need as much as 20 to 1 carbon to nitrogen ratio, where bacteria typically are 5 to 8 to 1. Now, in our crops, which we're doing here, corn and soybeans, which one is fungal dominant and which one is bacterial dominant between corn and soybeans?
Soy is fungal.
Soy is fungal dominant, and corn is more bacterial dominant.
Now we know.
I will say that connected to that land-raised prairie undisturbed is 15 to 1 ratio fungal to bacteria. So when we have this idea that it's a 1 to 1 ratio or different ratios, unadulterated environments are massively fungal environments, and that's what's sharing information and energy and nutrition amongst all of them. They actually can share the same network, and one root actually has connected with 2 different plants. Like, it's absolutely amazing, unless you don't have it. Oh yeah, it's
like an internet.
yeah. It's a net.
It's a net.
It's 3-dimensional connection, always.
And the bacteria can use it for a highway for moving up and down.
Well, what is so important for us on soybeans? You got to have the nodules. You got to have the nodulization. Why? Because that is where the nitrosomonas and nitrobacter colonize on those nodules, which are actually sugar balls. Basically, that sugar is where they're colonizing. That's their food source and energy source, so that they can then do those conversions that are necessary, because we've got to convert that NH3 to NH4 to ammonium to be able to get the nitrosomonas to convert that to nitrite by adding an oxygen, and then by adding one more oxygen, we're converting the nitrite to nitrate with nitrobacter. These are aerobic bacteria. This all fits, it all works. It's just looking at nature, and what you were saying is correct. In the forest, who are the degraders? Who is predominantly degrading all the material in the forest? It's the mycorrhizae, it's the fungi. And a very good friend of mine from Missouri that's here in the audience, he'll tell you real quick, you can't have a bacterial party without a fungi. Just saying.
And I think, this is something that we need to understand. The industry, we have created cellulose and lignin degrading bacteria, but we need to be cautious because we need the fungi. The biggest limiting factor in this whole picture of biological development is who can come out with good, consistent, high quality fungal materials to add to our system. We don't want it to be completely bacterially oriented. Right? That's not good for us. We know we need fungal materials, and we're all waiting patiently for people with good backgrounds in mycology and other places to provide those fungi, because once they do, wow, watch what happens. We're going to step back and see a brand new level of activity in the soil if we can get that. If we can get them and get them to survive on the plants that we have and the food sources that are there available and we can provide, we got a whole new game on.
I'd love to talk some more, because we do have that. That's why I'm here, is because I've listened to the community as a whole for years tell me all the problems, whether it be in real life or watching a YouTube video of a conference in the past, saying the exact same thing. That's what I've spent my last 4 years finding. And we have it at scale. We have liquid products to make it user-friendly, but it is from nature. And it is off the charts when it comes to the fungal components compiled by nature, put together. It includes mycorrhizae and all the saprophytes, and it's yay nature.
Do they get along with Do they get along well with others?
The nice part about it is because it's biologically refined, like nature made it, it's then put within humic and fulvic crystals for stability, right? At which point they're in a cyst state, so they're dormant. They're not interacting or feeding off of each other because this was put together to be put back in the land. We're the head start that allows us to utilize it at scale. Spores, as well as what are considered colony-forming units, so active fungal hyphate growth. So spores as well as the hyphae.
And when the hyphae is in growth, will that have any effect on if you spray it at high pressure? Do we need
It does, but that's mesh size and pressure. So anything less than 40 pounds per square inch, anything greater than 40 pounds per square inch is going to blow this stuff up. So that's why less than 40 pounds per square inch. Mesh size is depending on what your equipment is. See, this goes back to our tool sets, our toolbox. If you're worried about breaking your spray rig, well then you're not worried about the biology. And so at that point it's finding the balance between a mesh size and an emitter size or whatever your time frame is to get it out on your plants.
Are the fungus single carbon metabolizers?
No, lignans, the whole gamut. And this is where I've learned a lot about the community I went to acres, everybody shut me type thing. It was like, I have what you guys are talking about, right? But it didn't meet their product list, or it didn't come from the right whatever. And I'm going, yeah, but this comes from nature, and here's all the testing, and here's everything else. When we utilize complete systems, even if it's the tiniest, but still a complete system, it's naturally biologically buffered. And that's why when we utilize humics and fulvics and these different things, it also creates greater efficiency in use of the poisons, things we want to stay away from, because it's buffering the plant's ability to handle that toxicity as well. And that's cation exchange capacity, and it's all the nutritional components. But we do have a nature-produced solution that replaces the fungal bacteria ratio. And it makes perfect sense that it would, because the animals that produce this are mycophages. They eat fungi. So all those spores, they go down those gills on the mushroom and consume billions of them, and then pack them together with the rest of the, this has been studied, and it's a biologically complete compost, represents all of the trophic levels of the microbiome, at which point when you put it out there, you're putting out the best nature can do.
I would say he's going to be the next millionaire. You should ask him to pay for dinner today.
Once I make the
That's good news, because I mean, I don't know anything about it, and I would love to visit with you, but that is exactly where this whole thing has got to be heading, because there's only so many bacteria, you can only develop them so long, and you need to be able to take the entire cycle and finish it off.
And when we're as individuals saying, why am I not getting a response? And yet we don't know how to read a label that says it's 98% fluff, inert ingredients, it's filler. And so at that point, when we're taking filler and we're putting it out there, we're not actually putting back the biology, the herd, the creatures. We're putting back the product. It's a totally different mindset. That's why it's not a technology, it's biology. It's a lie.
Bob wants to wrap this up in about 10 minutes, so we'll ask each member to take 1 minute or so and just give us a closing thought on whatever you want to say. We'll start at the end.
Okay, well, I'd like to do something since they're both back here in the room. I'd like to have my son and my son-in-law, Andrew and Craig, just stand up real quick so you can see them. Because I know with my gray hair, you're wondering, oh my, what about this carbon works? Is there anything behind this? Well, those young men have been with me for 8 years now, and every drop of product that any of you have used in this room or will use in the near future, they run our operations in Atlanta, Georgia, and build those products for me. And I'm very blessed to have them on my team. And you can see that we've got our succession plan in place and moving forward.
Thank you for coming, for staying educated, getting educated, having patience with us poor eggheads, because we know you need the help. We know you need the information. We know you're hungry for it, and we know you need it delivered in different packages. And this is an effort for us to simplify and educate for you, one of the most educated groups in the world. You need education, not indoctrination. And you are here today, thankfully, in numbers, and this is encouraging to us because we know we are involved in making a difference. And we know that you will be too. So thank you for coming, and please continue, if you will, to have patience with us poor eggheads, because we are well-intentioned. We just don't know sometimes how to do it right. And whatever feedback you're willing to give us, trust me, we are willing to listen. Because we need you to be successful, because if you aren't, neither will we.
I guess thank you for having me here today. I'm going to go back to this guy's question earlier, and how can we make our chemistries last longer and not wear out their welcome or their time? Like glyphosate's ran its course, dicamba and glufosinate is on its way. But really is how can we help not have those losses? Once correcting the pH of the water, what you can do for coverage, how you can penetrate the waxy cuticle of the weed leaf and get down and kill that weed. And then also what you can do for tank losses. I mean, avoid going out in the middle of the day, what this guy is talking about, when it's 90 degrees outside. Do what you can to eliminate the foam in your tank. Like 30% of your active ingredients is lost in that foam. So, little things that can help, and I think that Larry and Jeremy and Andrew actually have some products that can help you with that.
Well, I don't know about you, but my brain is pretty full, and that's a good thing leaving here. So we've heard a lot about the ag side, so I want to pull a tidbit from my education background and share it. And at the time, we did a lot of studying to figure out how people best learned. Lecture, was it movies, videos, whatever. The answer was students learn the best, and adults fall into this, when they A, do it, and B, learn from each other. Close 1 and 2. So I'd just like to take an opportunity to share that tidbit and use that to encourage all of us, the power of sharing and the power of knowledge that we all have, even in things that may not seem relevant. By discussing that with each other, we've learned to network. There's a lot of information that we can glean from each other and use that to move forward and make progress. So I want to encourage everybody to do that and echo what these guys have said, and thank all of you for being here, and thank Larry and Dee Dee and Bob and Carol for allowing this to happen.
Well, I'm with Andy. My head's spinning. I've learned an awful lot today, too. Larry will attest to this, as my wife. My vocabulary is not very big, and there's a lot of really big words used today that I'm going to have to go back and look up. And one of the things we're doing here is that this whole day has been video recorded, and will be available at some point to be able to go back and review and what did that guy say, and what was that word again? I wanted to go look that up and that sort of thing. So keep that in the back of your heads that this is being recorded and will be available to review down the road.
Oh boy, this again, thanks everyone for coming. I grew up in a co-op world, worked in the co-op system for 33 years, and decided to do a little side business after I retired and did some consulting, and it's grown to working with biology, with all the stuff we've talked about today. I never thought it would grow to this extent and talk about what we're talking about today. It's completely different. We need to rewrite the book on crop production and fertilization and all the things we talked about today. And I guess all I'll say is we're striving to do what's right. And I feel like I've screwed things up for the first 33 years. And we're trying to do better. So that's what our goal is. And I think that's why we're doing this today. So thanks for coming.
Thank you for coming. I guess I'm more of an interpreter of what is being told, not a speaker at hand here. But I appreciate you being here, and we'll see you all tomorrow.
I'll step in for Vatche. Drink water, Dr. Rich. I see you in the box.
will have to rewrite their biog and say comedian. Okay, first of all, I'd like to say, let's have a hand for Carol, because it wasn't for her. That's a technique she used when she ran the medical clinic for over 30 years. But I like what Gabe Brown said. He said, they used to laugh at me because I was different. I thought different. Now I laugh at them because they all think alike. So the fact that you're here today wanting to learn, better your knowledge is really encouraging. And Paul Kachati from Spring Valley, Minnesota sent me a story where it said they view a great threat to the U.S. farmer if they continue to say, for the health of our people, we want to import non-GMO food. Now, isn't the first rule in business to find out what your customer wants and then deliver to them? So if I was manager of a large grain facility, I would get right down there, meet with them, and see if I could accumulate train loads of grain to meet their needs. And was in Russia and met with a bunch of Russians at a conference. And they asked Putin what he thought of GMOs. He said, at this point, I won't let them in this country, and I will watch and see what the health of the next generation of U.S. citizens is before I make my decision. You know, he's being very prudent with it, and he's protecting the health of the U.S. citizens, or of his people. And I'm not sure what the rulers in our company want to have happen to us. You know, if they're flying chemtrails over us all the time, what's their goal? So I'm doing everything I can to destroy their wish.
City of Alpena is approximately 12,000, 13,000 people, and because of supply chain issues, they ran out of fluoride. So they went and searched out their new options, and it was going to cost $55,000, and they had to buy a hazmat suit. So I went to the meeting because my mother lives in this town. I says, our county doesn't have a hazmat suit. What is wrong with you if you think it's good to put fluoride in the drinking water if you have to have a hazmat suit? So the editor of the Letterers and the Mapers, well, it's good for the children's teeth. It's all about the children. It's all about the teeth. And take them to the dentist. Now we need some toothpaste. Take them to the emergency room. So I went to the meeting, and meeting after meeting, I take my pile of books, and I said, I wrote all these books. The last book I wrote was 87 pages about the loss of IQ putting fluoride in the drinking water. And I give it to him. I says, this is the last book I want to print this week. It cost me $220 to go in there. And of course, this kicked the can down the road. I said, now I know you're going to vote on this. And it's going to be either you're going to vote to give children a really bad IQ, or you're going to vote to let the children come out of poverty without an IQ. That is on you. As farmers, if you make this transition, your product is going down the road. My dad said, I don't give, I better not say it, my phone's ringing. He's calling. He says, I ain't going to be around, what do I care? And I'm like, you don't care about your grandkids? And we had a little disagreement about that. But if you have a product that's going to go into the animals, that's going to go into the human, obviously, you know, morally, you want to do what's right to make sure that we're all being fed right. And it's got to have all the minerals, and it's got to have the fats and the oils and all that stuff that goes with it. And thank you for coming tonight.